Time for some fishing. Chris, welcome
Thank
virtually
you.
to our room. Um, Chris is going to tell us everything about advanced fish. So probably if you've already done fish and then want to go on. Chris is from MITRE, so he knows everything about it, I presume. I'm keen to hear it. Go along. Oh, and questions, do you want to have them during the session or at the end of the session?
Let's go ahead and save them for the end.
Yes, and online participants can put them in the Q&A session of the WUVA and we'll monitor that as well.
Okay. All right. Thank you for coming to Advanced Fish, What to Do When You're Hooked. My name is Chris Moesel. I am a Principal Health Technology Engineer at the MITRE Corporation. I'm also the co-creator of FHIR Shorthand with Dr. Mark Kramer. And I'm the development lead for the FHIR Shorthand tools like Sushi, Go Fish, Fish Online, and others, as well as a technical lead for the Agency for Health Research and Quality's CDS Connect project here in the United States. I work for MITRE. MITRE is a US nonprofit. We operate federally funded research and development centers working across many different sectors of the US government. Health is one of those sectors, and we try to bring conflict-free perspective to our government sponsors. So in this course today, we're going to dive deep into a few specific areas. One is managing large lists of items in fish. Another is using rule sets to leverage common code, slicing, as well as converting existing IGs into FHIR Shorthand. And then last, we'll cover a few of the things that are upcoming in the next fish ballot, as well as in the new Sushi 3.0. So first of all, if you went to the Intro to Fish session, hopefully you enjoyed it and you walked away thinking, this is pretty cool. But why is fish so awesome? Because it's scalable. All right, I just had to fit that one in, and now we'll proceed to the business. So I don't want to spend too much time on basics, but for anybody who skipped the intro session, FHIR Shorthand is a language for creating FHIR profiles and other artifacts that go into FHIR implementation guides. It has a pretty common structure of a declaration followed by some keywords and then some rules. And those rules are what do the real work of constraining things and things like that. This is an example of how you would actually do a profile on the bottom left-hand side for body weight. That's as much time as I'm going to spend on the basic because we have a lot of advanced to cover, but you can look at the slides. So the first thing we're going to look at is tackling tediosity with soft indexing. So in FHIR Shorthand, we do allow you to create long lists of things if you'd like. Usually this is done in instances. On the left-hand side, we see an example of what presumably comes from a questionnaire that has a number of items. And the way that we taught you to do this in intro is to use numeric indices. So you would start the first item with index 0, the second one index 1, etc., and you would just keep on numbering those. Well, that works okay up until a point when you want to insert an item right in the middle. When you do this, now we're in a little bit of trouble because that item, where we want to put it, it needs to become item with index 3. However, we already have an item with index 3, so that one will need to become item with index 4, and so on and so forth. And it starts to get pretty complex. There are some other problems with explicit indexing as well. It can be error prone. Sometimes I might miss a number. I'm not the best counter. Sometimes I might repeat a number by mistake. When you do that, it just has this cascading effect that's really kind of annoying. So the way we address this in FHIR Shorthand 2.0 is we introduce something called soft indexing. And with soft indexing, you can use special symbols to do relative indexing. So we can use the plus symbol to say, I want to move on to the next item in the array. And we can use the equal symbol to say, I want to reference the last referenced item in the array. So in this way, we can still create a list like we have here on the left-hand side, but instead of using explicit numbers, we're using relative placeholders. So we're saying, the first item is this, and then the next item is this. That way, when we want to insert something in the middle, we can just do that, and it works because the numbering is all relative to each other. So we like this one because you don't need to count. Like I said, counting can be hard. It's easy to add and remove items. And it's also much friendlier for copy pasting and using rule sets. So rule sets, what are rule sets, you ask? Well, I'm glad you asked. That's the next thing we're going to talk about. Sometimes you might find as you're writing FHIR shorthand that you have a set of rules that you use in a lot of places. What rule sets do is they allow you to define these common rules in one place and then apply them multiple times throughout your implementation guide. On the left-hand side, we have an example here. We have a contact and copyright rule set. And in that rule set, we're just using some rules to set the underlying contact and copyright for a FHIR resource. Now, this could be applied on a profile, an extension, a value set, a code system, because all of them have these underlying contact and copyright fields. Now, the way we actually do the application of the rule set is through something called an insert rule. So on the middle, on the left-hand side, we see a profile, and we see that it says insert contact and copyright. This is applying that rule set. So when it runs through Sushi, Sushi is going to take that contact and copyright. It's going to expand it in that profile definition. And then it's as if we had put those contact and copyright rules right in the profile, except for we didn't have to type them all out again. And that way I can do that in multiple places and just reuse that same bit of code. But wait, there's more. We also noticed that oftentimes some of these patterns of rules are very similar, but they just change in slight ways. There's just some values that might be a little different. And for this, we created something called parameterized rule sets. So parameterized rule sets are like regular rule sets, except you can also declare special parameters that will have placeholders inside the rules, so that whenever we actually apply this rule set, we can specify what values we want to take the place of those placeholders. So on the left-hand side, we have an example with a rule set that sets the context for an extension. It declares two parameters, type and expression, and then it applies those parameters inside the rule set to the type and expression context elements. So in the middle on the left-hand side, we have an example of how you would actually use this. We would say insert the name of the rule set, context, for open parenthesis, and then we would do each of our parameters separated by a comma. And then finally, we close it with the closing parenthesis. And when that goes through Sushi, it does that substitution for us. It applies those rules with the values in the placeholders, and we end up with what we're looking for. And so now we can take this set of rules and use it in multiple extensions, but each might have a slightly different context, and that's okay. Now, it's important to note that this works like a simple find and replace, literally like if you're doing copy replace in your editor, with one exception. If you want to insert literal commas or closing parentheses as part of your value, then you need to escape those using a backslash, because otherwise, if you don't escape them, Sushi is going to think that comma means that you're moving on to the next parameter, or that that closing parenthesis means you're done with the insert statement. So you need to escape those if those should be literal values that you're passing into the rule set. So let's look at a more real life example. Here is a part of a capability statement from the Saner IG from a while back. If you look at this, there's a lot of text there, right? If I asked you to tell me what is this saying, it would take you a couple minutes to look at it and figure it out. So let's see if we can use rule sets to our advantage here as well. Well, the first thing we're going to do is convert these to use soft indexing. And that helps. It tightens things up a bit, but it's still pretty difficult to understand. But more importantly, now, because these are relative, we can actually fit them into a rule set and it'll work wherever we put it. So let's talk about extracting some of these common bits here into rule sets, because I see there's one bit that's about how do you support a resource. There's another bit that's how do you support a profile, and then there's another bit that's how do you support an interaction. And each of those groups of rules can be made into a rule set. So here's our example rule set. We have a support resource rule set that takes a resource and an expectation, a support profile rule set that takes a profile and an expectation, and a support interaction rule set that takes an interaction and an expectation. And it defines all those gnarly rules within the rule sets, right? So now when we actually are doing the real stuff we want to do, defining that capability statement, we can just use these rule sets and say insert support rule set resource for measure report with a shall expectation, for this particular profile with a shall, for create and update. And you can see that's much cleaner. It's much easier to read. So when we actually apply that to our previous slide that was like really messy, this is what it comes down to. Now, if I ask you, what does this mean? It's a lot more clear because we've been able to really simplify it through the use of rule sets. So rule sets, when used correctly, can really help code become more compact, easier to read. As an author, you make fewer mistakes because you don't have to type all those complicated things quite as many times. You just do it in one place. It also allows for more consistency throughout the IG because everywhere where you apply that rule set, it's going to be applied the same way. It's easier to write and it makes for happier fish. So rule sets, you should check them out. Now, one thing about rule sets and soft indexing is that sometimes it can make debugging difficult. So if you've ever gotten an error in the implementation guide publisher that says, oh, there's something wrong with entry number 78 in your bundle. If you use soft indexing, which just has pluses, it's going to be hard to figure out which entry is number 78. So if you run sushi with a -p flag, that will export some additional pre-processed FHIR shorthand. So now you can look at your FHIR shorthand definitions, seen here on the right-hand side, and all of the aliases will be expanded. The rule sets will be expanded. The soft indexing will actually be made into explicit indices. So now it's easier to look at that and see, oh, entry 78 is my, allergy intolerance entry. And now I can track it down in the original fish a lot easier. So that's pre-processed fish, a neat little feature in sushi. But now we're getting to the real fun stuff, slicing. Slicing is something that scares some people. So we're going to try to go through slicing without losing a finger. So first of all, what is slicing? If we really break it down to its simplest, slicing is about taking a list of things and subdividing it into smaller lists. So for example, I might have a grocery list here. And that grocery list is okay, but if I take that to the grocery store, I'm going to have a little trouble because it's not organized in any way, and I'm going to find myself all over the grocery store. So usually when I write a grocery list, I split it up into categories. I have my produce, I have my meat, and I have my dairy. It's the same list, but now I've just organized it into groups. That's essentially what slicing is. Each of those groups is a slice in FHIR. We have our produce slice, meat slice, and dairy slice. That's essentially what we're doing with slicing. So in FHIR, there's a few rules to be aware of when we do this. One is that slices must be mutually exclusive. So I need to define my slices in a way that it's very clear where any given item goes. If an item would fit into more than one slice, then I've done it wrong. These slices need to be clear, explicit, mutually exclusive. We sort items into the slices using something called discriminators. So discriminators tell us, what is it that I need to look at about the item in order to figure out which slice it goes into? So for example, in our grocery list, we might slice with a discriminator of the aisle number. So we might know, produce is in aisle 1 and 2. So we'd say, okay, our discriminator is the aisle number, and aisles 1 and 2 go into produce, aisles 7 and 8 go into meat, and aisle 10 goes into dairy. And we're discriminating on the aisle of the item. We can also apply different constraints to each slice. So now that we've separated them out into these buckets, I can say, ooh, for my dairy slice, I want to make sure that every item has an expiration date. Because if there's a dairy item that doesn't say what its expiration date is, I'm not interested in it. We can also optionally require slices to be in order, and we can optionally allow items that don't fit in any slice at all. So I could still put beer on my grocery list, even though there isn't a particular slice for it. One other advanced concept about slicing is that we can also reslice, which means we can take one of the existing slices and we can further divide it into sub-slices or reslices. So I can take my produce and I can say, ooh, I want a vegetable slice and a fruits slice as well. All right, so bringing this back to FHIR some more, the way this happens beneath the scenes in FHIR is that the element definition that describes a particular element in a resource has a slicing property. And that slicing property contains all the information you need to know about how the slices are going to be distinguished in this profile. It has a discriminator, which we just talked about, a description, whether or not it's ordered, and whether or not you're allowed to put extras. Within the discriminator, there is a type and a path. The path tells us what part of the item do we need to look at when determining a slice. So for example, okay, within this slice of components, you need to look at the code path. And then the type says, well, how are you going to compare that code path? Are you going to compare it by value, or are you going to compare it by pattern? Are you going to look to see whether or not it exists? Or are you going to look at its underlying type or its profile? Or lastly, you can actually say, oh, I want to look at the position of the item in the list. That's new in R5. Also new in R5 is the pattern discriminator type has been deprecated, and now you just always use value. So those are a couple of differences there. So this is an important thing to understand when you're trying to understand slicing. So let's look at a real world example, US core blood pressure. This is an observation profile, and the blood pressure wants to record systolic and diastolic components. So we're going to take that component list in the observation resource, and we're going to slice it and say, we want one systolic slice and one diastolic slice. Now, in this case, we only want one item in each group. So when I said you subdivide it into smaller groups, those groups can be groups of just one, which is what we're doing here. So when we look at this, we can see we are slicing by the observation components code, and we're doing a slice on pattern. So we're saying when we see an item in component, look at the code and check by pattern to see which slice it goes in. And you'll notice that in each slice, there's actually a required pattern. So it's a fixed value. And the first one says, okay, to be in this slice, you need to have a code LOINC 8480-6. And the second one, the diastolic slice, says to be in this slice, you need to have a code that says LOINC 846-62-4. And both of them also apply further constraints, like saying the value should be a quantity and it needs to have a particular unit of measure. So this is what the US core blood pressure profile looks like. Let's see how we would actually do this in FHIR Shorthand. There's 3 steps to defining slices in FHIR Shorthand. The first one is we need to define the slicing logic. We need to set those values that are in that slicing element in the element definition. The way we do this is by using what we call caret rules in FHIR Shorthand. These allow us to get to the underlying element definition or structure definition. So our rule starts with component, because that's what we're slicing. And then we have our caret, and then we have our slicing path, basically, that gets to the value that we want to set. So here we're saying we want a discriminator of type pattern and path code. The rules should be open to allow other values. Ordering doesn't matter, and here's a description. So this is the first bit, step 1. Once we do that, we identify what are the actual slices that we want to introduce. And we do that using a keyword called contains. So now we say the component array contains a systolic slice that should be 1, 1, and a diastolic slice that should also be 1, 1. So exactly 1 systolic, exactly 1 diastolic. So this is now introducing, these are the slices that I'm setting up now. And then lastly, we need to actually define each of those slices. So the first thing we want to do is make sure that because the discriminator is on code with a pattern type, we want to make sure that we are setting the code within each slice so it knows what to match on. So we set the component systolic code to LOINC 8480-6. This is just like any other assignment rule, except you'll note the way that we address slices. We address them using brackets. So we say component, and then inside of brackets, we put the slice name, and then we can do the dot and do the rest of the path. And that's how we address the things that are specific to the systolic component, and the diastolic component would work very much the same way. So that when it's all put together, we end up with a blood pressure profile that looks just like this. It's not too bad. It is still complicated because it's slicing, but this is essentially creating a simplified version of that US core blood pressure profile. All right, so that's slicing. We're just going to keep on moving through because 35 minutes is not a lot of time to get deep into fish. So now let's say that you've been to the intro, you're enjoying this one so far, and you think, I might want to go ahead and use FHIR Shorthand, but I have these existing projects and I don't know what to do with them. Well, the good news is you can use something called GoFish to convert formal FHIR profiles and other definitions into FHIR Shorthand. And that gives you a good jump start on using FHIR Shorthand for that project. It's a quick way to do a conversion. GoFish is also helpful for just learning about FHIR Shorthand, taking a formal FHIR JSON definition and saying, what would this look like with FHIR Shorthand? Push it through GoFish, and you can find out. So GoFish is actually fairly simple to use as far as just the way that you invoke GoFish. But I wanted to go into, and also you can tell it different strategies for how you want it to output your files. So you can say, I want a file per definition, or I want to group my profiles and my examples together in individual files, or group by type, or I'm a masochist and I really just want it all in one giant file, right? You can do that. And then after you run GoFish, you can still move stuff around as you see fit. But really, one of the interesting and more difficult components of GoFish is just figuring out, like, what did it do, and did it make any mistakes, or how are things different? And that's what fishing trip is for. What fishing trip will do is it will take your input JSON files, it'll convert them into fish, and then it'll take that fish and it's going to run it through Sushi and convert it back to formal JSON files. And then it's going to do a comparison between the input before fish and the output after fish. And the result of that comparison will be listed out in a web page, and you'll see each file and what's different. And there will be differences. For sure, there will be differences. The question is, do those differences matter? To do that, it's a little bit of work. You need to actually go through and look at those differences to understand them. So this is an example of an observation profile. I forget which one, but I think it's from US Core. And we have some differences here. If we actually look at these differences, we can see, this might be a small screen for those in the room, I'm sorry. But the top difference basically is on the left-hand side, we have a coding system and then a code. And on the right-hand side, we have a code and then a system. Well, it turns out this doesn't really matter because the properties are just in a different order. And JSON says it doesn't care about order of properties within an object. Right below that on the left-hand side, we have a must support flag set to true. But on the right-hand side, which is what comes after GoFish and Sushi, it's gone. Well, it turns out that's okay too, because that was inherited from the parent. And since we're looking at the differential here, we don't need to include it because it's not, in fact, different. So that's okay too. The next one on the right-hand side, you can see this big block. That's actually a type declaration. So in the original source, we didn't declare the type in the differential. In the source after running it through GoFish and Sushi, we do have the type. Well, it turns out that's okay. That's actually following best practice because it's in a type slice. And when we're in a type slice, best practice is to go ahead and redeclare what that type is. So the source wasn't wrong, but the new one is better. And then on the bottom, we have another case of some properties that actually did not change from the base resource that they inherited from. So they don't need to be in the differential, and FHIR Shorthand just took them out. So those are all good. But now we get to this one where on the left-hand side, we have an entire slice called US core / social history that's just missing. It just went away. So we look at this and we thought, better investigate. Little fish pun there. As it turns out, there were some clues that something might be going wrong when we ran Go Fish and Sushi. When we look at Go Fish, there's an error at the bottom that basically says US core / social history is not correctly used to populate the ID for this element. Well, that message itself is a little fishy. It doesn't make a lot of sense to me, but it is an indication that there's something wacky going on here. Right below that, we have a message that was output by Sushi. This one says there was no element found at the path category US core. So what that's telling me actually is that in the original source, we have an element that has a reslice, because remember the slash is a reslice. So US core / social history is a reslice of US core. However, that profile and its ancestors never introduced a US core slice at all. So it's actually an issue with the original source that we were translating that caused this problem. So it's good to be aware of that. So a few Go fishing tips when you're using it. It works best when you do it on IGs that have a clean QA, no errors, because you've heard the phrase garbage in, garbage out. Well, you want to make sure you've got good clean input coming in to get good clean output. So for that same reason, ideally, you want to use something that's like an officially released package if possible, or at least something that's been built with some real tooling like the IG publisher or one of the FHIR tools or something like that. If possible, you want to use packages that contain the profile snapshots, because this helps Go Fish get a little more context when it's doing its processing and makes for better FHIR Shorthand in the end. And you also want to avoid duplicate files or non-FHIR XML and JSON files as much as possible. Some things to note: Go Fish or Sushi might find some problems in your original source, and that's okay. But also note, Go Fish is not perfect. We have done our best. We have tried to address as many issues as we are aware of. However, sometimes, there's some wacky stuff that goes in and wacky stuff comes out. So you always want to review your generated FHIR Shorthand and the final outputs. And there's always opportunity as well to optimize the fish that Go Fish has generated, because it's not always going to be optimal. Again, we try, but it won't always be that way. All right, I'm down to 2 minutes already. Okay, my timer must have been wrong. I thought I had 35. All right, so Go Fish in a hurry. You can use FHIR Shorthand Online to also do a conversion from formal FHIR resources to the FHIR. All right, so speaking of in a hurry, let's talk about what's new. In FHIR Shorthand 3.0, you can do instances of logical models. In FHIR Shorthand 2.0, you couldn't, mainly because the IG publisher really didn't support it, so we didn't want to support it either. Now the IG publisher supports it, but you need to jump through a bunch of hoops. So we tried to make it really simple. In FHIR Shorthand, you can define instances of logical models the same way as you define instances of anything else. And we'll jump through all those hoops behind the scenes for you so that you get those instances in your implementation guide. We also added support for extension context. So extension context is important. And previously, you had to define context using caret rules. Now you can use a special keyword, and we have some magic FHIR Shorthand syntax in there as well to help you with that. Invariants used to be you had to always use keywords. Now we allow for keywords or rules, which makes it look a lot more like all those other fish definitions we have. But more importantly, it allows you to actually introduce extensions into your invariants, which you couldn't do before. So now you can more easily label that invariant as best practice. We have a whole way of escaping, because sometimes when you do rule sets and you try to insert items, it can be really annoying if you're inserting FHIR path or post-coordinated SNOMED because you have to escape all those commas and closing parentheses. We introduced a new way to avoid that using a different syntax. I'm not going to go into this last thing, but we changed some ways of doing slice ordering that we think makes it more consistent, but right now it's an optional feature. And then lastly, more puns, of course. So if you don't download Sushi 3.0 for any other reason, download it for the puns. Okay, well, that was a wild ride, very quick. Thank you for joining us, and I am open for, oh, now I have 5 minutes remaining again. It changed. Well, that's okay. I just barreled through those, so I'm open for any questions that you might have.
Yeah, that was a slight mistake from the moderator, but it did give us a bit more time for questions, and also you could, of course, request special explanation of one of the slides that Chris just rushed through. Anyone? Yes, here.
Okay, thank you for Sushi. It's a really good tool. I wonder if there are plans to implement something like hot reload while running Sushi.
I'm sorry, could you repeat that? To implement what?
Hot reload.
Oh, hot reload. Oh, okay, yeah. So we've thought about that before. The short answer is no. We've thought about it before. However, I think there would be quite a bit of work that would be needed to do that. And we haven't really had enough people asking for it to justify the work that would be required. So we're really focusing more on, new features, fixing bugs, and actually, we spend a good amount of time just keeping up with the IG landscape because, Graham and Lloyd and all their friends are always adding new things that you can do with the implementation guide publisher or things like that. So often we're investing time just trying to keep up there too. But it is an open source project. So if somebody can find a way to do hot reloading without having to rewrite the whole thing, then we're very happy to take a pull request.
Anyone else? Yes.
But often I will say, when people want hot reloading, it's because the full build takes too long. So we do want to try to improve build times when we can too, and every once in a while we'll spend a little time looking at that. So that is something that we would like to improve.
Hi, Chris. Thanks for the presentation. A more practical question. You have an extension in VS Code for FHIR Shorthand. I was wondering, does it support R5 completions? And if so, how can we easily configure that?
Right. That is a good question. I was going to say yes, it does, but now that I've thought about it a little bit more, if it doesn't, it's just a matter of we should be able to support it pretty quickly. When we initially did the completions, I think that R5 was not quite yet available. And so we might not have just done all the plumbing to make that work. So if your experience is that it's not working with R5, then I think that's something that we can address. However, maybe it works. It should be the underlying mechanism for supporting R5 is all there. It's just whether or not we actually told it how to find the R5 definitions.
Well, I don't think it supports R5 because I still have the completions on assert or on condition instead of what is it now? It's changed participant.
Okay, so I'll take a note to look at that, and I expect we should be able to update that pretty quickly now that we're better aware of the issue. Thank you.
Anyone?
I also want to say thanks for Sushi and Fish and I noticed that about 2 weeks ago, you uploaded FHIR package loader, an NPM module.
Mhm.
Is that really the mechanism that Sushi uses to download packages? And is it still maintained? That would be my question.
Yeah. Yeah, so in fact, with Sushi 3.0 that we just released earlier this week, that's the first version of Sushi that's now using that FHIR package loader, because we found that, we have Sushi and we have Go Fish and we have a few other things, and they all needed to load packages. And so we decided to extract that into a single module. So we are maintaining it. I'm not sure that we have the exact API right on that module, so there may be some changes to the API, but we're using semantic versioning. So if we do make some changes there, then we'll version it appropriately. It is pretty well tuned towards things that Sushi and FHIR Shorthand tools need, but might not be as better tuned for other generic tools that might want to load packages. So if you want to use it for something and you find that it needs some additional work, let us know. But it is out there, it's free to use, and it is maintained.
Great, thank you.
If that's it. Oh, I'm sorry. Looking through all of the room.
Okay, thanks from me again for Sushi and Fish. I learned about it this week and I'm hooked. And I downloaded the VS Code extension for and using the autocomplete for the templates for profile and such. And I wondered, is it possible to more or less override those templates with my own version of it?
Can you describe that a little better? What do you mean? What do you want to override?
For example, if I type PRO, I'll now get the basic profile elements. But what if I always want to do an insert of the copyright and the contact information?
Okay.
And more or less of those.
Right. So we call those snippets.
Okay.
And there are ways, so snippets are a feature of Visual Studio Code that we can use in extensions for Visual Studio Code. Regarding how easily you could override those, that would be, I think you'd need to look at the features of Visual Studio Code to figure that out. I don't think there's a way, we haven't built anything specific into our extension to support overriding those. It's an interesting idea because I guess we probably could have extension settings that essentially would allow you to say, oh, I want you to also add these additional things to the template. So that's an interesting idea. But right now, I'd say I think that Visual Studio Code has general support for snippets. How easy it is to add that just as like a general user, if you're not defining your own extension, I'm not sure. But I could look at that and then just kind of post something on Zulip. Do you follow Zulip, like the chat.fhir.org?
It means I have to now.
Well, I can post something. Actually, I can post something in the Whova. I'll post something in the Whova comments or Q&A section. I'll just do a quick look to see if there's anything simple, and my answer will probably be either like, nope, you can't do it, or yes, you can, and here's a link.
Yeah, actually, to comment on that, you can easily add snippets with the same prefixes. They just add up in the autocompletion. So yeah, if you want to have an example, I can share. Okay.
Great.
Community help. That's what it's about here. Great.
It is.
Anyone?
Okay. I've been having troubles with slicing. All the examples I see about slicing are just something that's an array one level deep. But what if I want to slice the code of a codable concept that it itself is can be more than one? I really can't figure it out. So if anyone here can help me. Okay.
Okay, his neighbor can already show it. Not sure, Chris, whether you want to show it how to do it in Fish.
It might be a little difficult for me just because I'm only sharing my slides right now. I'd have to like switch my sharing up to be able to show other things. What I will say is that, yeah, so, you know, deep slicing is something that can be done. I think we do have some examples of it if you're just looking through Zulip. The one caveat I'll say is that if you're using the IG publisher, my experience has been that sometimes things, when you get into deep slicing with the IG publisher, sometimes the validator doesn't always work the way that you think it will work. And, you know, I think that we're all kind of working through that to figure out in those cases, whether it's a validator issue or, you know, whether it's the way the slices are defined or what have you. But sometimes just, especially if you're doing something really complicated with slicing and the validator is not working the way you think, it's not necessarily that you're doing things wrong. You may be just doing something that nobody had anticipated and isn't yet supported in the validator.
I would take that as a compliment. All right. I think there's no further questions on Whova either. So thank you very much, Chris.
Thank you.
And I hope to see you live in the next DevDays.
I hope so too. I hope so too. And kudos to all of you for showing up at the last presentation on a Friday. I really was not expecting anybody to be here. So thank you so much.